In our previous video, we looked at linear functions and we went through the process of using the function to plot a straight line given the domain. In this video, we're going to look at the first one is the length of a straight line, then the midpoint of a straight line, the gradient of a straight line, and the equation of a straight line. So let's get into it. The first thing we're going to be looking at is the length of a straight line. Now you have the formula there. AB is equals to the square root of x2 minus x1 all square plus y2 minus y1 all square, where x1 and y1, x1, y1 and x2, y2 are the starting and ending points of the line. Now if you're finding the length of a straight line, therefore you have to use the 2 points that are at the ends. That would be the point where the line starts and the point where the line ends. And our starting point, we say x1, y1 because this point carries 2 coordinates, and our end point is x2, y2 because this point also carries 2 coordinates. So we're going to do an example and use the formula to show you how we find the length of a straight line. This is the example we're going to be working with, and we're now going to work the A part. From the question, we write down our 2 points. We have P is 3, -5 and Q is -9, 10. So we have to find the length of PQ. So before we go to this, we have to assign X and Y to our 2 points. So since this is the first point, we say this is X1, Y1, and this is X2, Y2. So the first point is X1, Y1, and the second point is X2, Y2. Now what we have to do is to substitute these values into the formula. So let's do that. So you have the square root of x2, which is -9, minus x1, which is 3, all square, plus y2, which is 10, minus y1, which is -5, all square. This is going to be the square root of -9 minus 3 is going to give me -12 all square plus 10 minus -5 is going to give me 15 all square. This is going to be the square root of 12 square is 144 plus 15 square is 225. Adding them, I would have 144 plus 225. That's going to give me 369. So to find our answer, it would be the square root of 369. So the square root of 369 is going to give me 19.2 units. And this is the length of the line PQ with points 3, -5 and -9, 10. Next we have the midpoint of a straight line, and the formula is m is equals to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Now when we're finding the midpoint, we're actually finding a point on the line. So x1, y1, x2, y2 are the starting and ending points of the straight line. So let's say you have a line and you want to find the middle. You'd have to use the starting point and the ending point, and then m would be the point in the middle, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Remember that this is a point, so you need an x coordinate and a y coordinate. So you're going to use the 2 points given and you're going to find the midpoint of a line. We are now going to work the B part of the question, and that is the midpoint of the line PQ. In this example, we have to find the midpoint of the 2 points PQ, and P is 3, -5 and Q is -9, 10. We have our formula here, so let's identify our coordinates. So this is x x1, y1. This is x2, y2. So let's substitute them into the formula. So m is equals to x1, which is 3, plus x2, which is negative 9, divided by 2, and y1 is negative 5 plus y2, which is 10, divided by 2. Three plus negative 9 is going to give me negative 6 divided by 2, and negative 5 plus 10 is going to give me 5 divided by 2. So negative 6 divided by 2 is going to give me negative 3, and 5 divided by 2 is going to give me 2.5. So our midpoint for the line PQ with coordinates 3, negative 5, negative 9, 10 is 3, negative 2.5. Now this is in worded questions. Let's say now they ask you a question and you had to actually draw the line. Remember, you're using the two endpoints. That would be our starting point and our ending point. So if you're given a question to use a linear function to plot a straight line, and then they ask you to find the midpoint of that line, remember you have to use the two endpoints for the line in order to find the midpoint. The third thing we're going to look at is the gradient of a straight line, and the formula is m is equals to y2 minus y1 divided by x2 minus x1, which is the change in y divided by the change in x, where x1, y1, x2, y2 are any 2 points on the straight line. Now let's say you have the line AB and you are using these 2 points here, right? If we use these 2 points, then the gradient, which would be the slope of this line, and if we use these 2 points here, the gradient again, which is the slope of this line, these two would be the same because it's one continuous line and gradient is the slope of the line. So the slope here and the slope here would be the same. So to find the gradient, you don't need the two endpoints. You could use any 2 points on this line and you could find the gradient of that line. So if you have a question that you have to plot a straight line, just use any 2 points on the line and put them into our formula, and you would be able to find the gradient of that line. We're now going to work the C part of the question, and that is the gradient of PQ. The example, gradient of, you have the 2 points there, P, 3, negative 5, and Q, negative 9, 10. You have the formula here, so let's just get our points. So this is going to be x1, y1, x2, y2. Put them into the formula. M is equals to y2, which is 10, minus y1, which is negative 5, divided by x2, which is negative 9, minus x1, which is 3. M is equals to 10 minus negative 5 is going to give me 15, divided by minus 9 minus 3 is going to give me negative 12. So if you are to break this down, you're going to get 3 5s 15, 3 4s 12. So the gradient is equals to negative 5 over 4, or we say 1, negative 1 and a quarter. So the slope of the line, or the gradient of the line, is negative 1 and a quarter. Note that this is a common m, and this common m is used to represent gradient. So when we go to the equation of a straight line, you're going to see the common m again. The last thing we're going to look at is the equation of a straight line. The equation of a straight line is y is equals to mx plus c, where m is the gradient, c is the y-intercept, x is the independent variable, and y is a dependent variable. Now we know how to find the gradient, that is using the formula that we just complete. M is equals to y2 minus y1 divided by x2 minus x1. C is the y-intercept. This means that whatever value is C is going to be the point where our line cuts the y-axis. So you have our x-axis and our y-axis, and let's say you have a line coming there. The point where this line cuts the y-axis is our C value, or we say the y-intercept. X and y, these two, would come from any point on this line. So it's going to be a point we're going to use, so we're just going to identify a point to use. Now, in our last video with linear functions, you had f of x is equals to 2x minus 1. So this is an example that we did before. So remember, we say f of x is the same as y is equals to 2x minus 1. So from this, if you could look back at the example, you're going to see minus 1 would be our C value, which is the y-intercept. And you're going to see that when you plot the graph, this line actually cuts the y-axis at the point -1. And from this, the 2 here is what we call our gradient, which is represented by M. So when you're when you're writing the equation of a straight line, the things that you need would be our gradient and the intercept. So the points are usually given, or you could find them on the line. So let's say you have to you receive a straight line and they ask you to write the equation of that straight line. You just have to use any 2 points, find the gradient, and after you find the gradient, use any other point and find our C value, and then we write the equation of the straight line. We are now going to work an example and you'll see exactly what I'm talking about. This is the example. You're going to pause the video and copy the question, and then we're going to work. So you have the example there. The 2 points we're working with is AB, and A is -2, -4, and B is 4, 2. And using these points, they fall on the line L1, and using these 2 points, we have to write the equation of that line. So we can remember the equation of a line is in the form y is equals to mx plus c. So the first thing we have to go and find is m, which is the gradient. So m is equals to y2 minus y1 divided by x2 minus x1. And just to mark off our points, this is x1, y1, x2, y2. Let's put in our values. M is equals to y2, which is 2, minus y1, which is -4, divided by x2, which is 4, minus x1, which is -2. M is equals to 2 minus -4 is going to give me 6, divided by 4 minus -2 is going to give me 6. So 6 over 6, my gradient is equals to 1. So we found M. Next thing we have to go and find is C. Now in order to find C, we have to use M and either one of these points. So I'm going to use B because we have 2 positive numbers. So using M equals to 1 and the point B 4, 2, we're now going to find the value of C. So let's go up here. So you have y is equals to mx plus c. We know that y, this is my x and this is my y, right? So y is going to be 2 is equals to m, which we found to be 1, multiplied by x, which is 4, plus c. This is going to be 2 is equals to 4 ones 4 plus c. We put all the known on one side and leave the unknown on the other side, so we bring this across. So 2 minus 4 is equals to c. C is equals to -2. So we found our m value, we found our c value. Now let's write the equation of the line. Therefore, the equation of the line L1 is equals to y is equals to m, which is 1 x, and we know c is -2. And if you want to rewrite this, it could be y is equals to x minus 2, because the 1 in front there is known. So this is the equation of the line L1 given the 2 points A, -2, -4, and B, 4, 2. Gradient of parallel lines. So when dealing with parallel lines, the gradient of parallel lines are equal. So you know what are parallel lines, right? You have two lines running alongside each other, equidistant, and they never touch. The gradient of our parallel lines would be the same, right? So you have an example here. Prove that the two straight lines are parallel, and you have the equation of the two lines. Now, when you're given equations like these, you have to write them in their general form, which is y is equals to mx plus c. And when you write it in this form, you're checking to see if the values of m is the same. So the first one, let's work with the first one. Y is equals to y minus 7x is equals to 9. Remember, you have to leave y alone on this one side. So let's take this over. So you have y is equals to 9 plus 7x. But this is still not in the form that we want, right? Remember, the mx usually come at the front. So rewriting this, we would have y is equals to 7x plus 9. So in this one, let's say m1 is equals to 7. Now let's use the other function and see if our gradient is also 7. So you have 2y is equals to 14x minus 5. We want y alone on one side, so that means we divide here by 2 and we divide here by 2. This and this goes, so we have y is equal, so let's just split this now because you have the sign there. It's going to be 14x divided by 2 minus 5 divided by 2. Y is equal to 2 1s, 2 7s, 7x minus 5 over 2. And if you notice here, m2 is also equals to 7. So since our gradients are the same, then we can say the lines y minus 7x equals 9 and 2y equals 14x minus 5 are parallel, because we just proved that the gradient for both of the lines are the same. Gradient of perpendicular lines. So the product of the two gradients equals to -1. So in order to say if two lines are perpendicular using their gradients, when we multiply the two gradients, we must get -1. So you have here proof that the straight lines are perpendicular, and they gave you two lines. The first one is 3x plus 2y equals to 7. Then you have 3y minus 2x equals to 5. Remember, we have to write these in their general form, which is y is equals to mx plus c to find their gradients. So let's work with the first one. The first one is 3x plus 2y equals to 7. We want y alone on one side, so we're going to take this across. So you have 2y is equals to 7 minus 3x. We want y alone. We divide here by 2 and we divide here by 2. This and this goes. So y is equals to, let's split this, 7 divided by 2 minus 3x divided by 2. But this is still not in this form, so we just have to switch these two. So rewriting it, y is equals to negative 3 over 2x plus 7 over 2. So our gradient here is m1 is equals to negative 3 over 2. Let's look at our second line. 3y minus 2x is equals to 5. So let's start changing this. We take this across because we want the y alone on this one side. So we have 3y is equals to 5. You take that across, it becomes plus 2x. We want y alone. Divided by 3. We divide here by 3. This and this goes. Y is equals, so we can now split it. 5 over 3 plus 2 over 3x. Again, it's still not in the form that we want. We need to switch these two. So y is equals to 2 over 3x plus 5 over 3. And this is my gradient. So m2 is equals to 2/3. Now we have m1 is negative 3 over 2 and m2 is 2/3. Let's try to use the rule, see if they are perpendicular. And the rule is m1 times m2 must equal to negative 1. So we found that m1 is negative 3 over 2 multiplied by m2, which is 2 over 3. That's going to give me 3 2's 6. So negative 6 divided by 2 3's 6. 6 and 6 would go. So my answer is negative 1. That means that the lines 3x plus 2y equals 7 and 3y minus 2x equals 5 are perpendicular because the product of their gradient equals to negative 1. So parallel and perpendicular lines, in some questions, they would give you the gradient of a line and then ask you to find the equation of a line that is parallel to that line. What you have to remember is that the gradients are the same, and with perpendicular lines, the same might come, where they might ask you to write the equation of a line that is perpendicular to the one that you have and they give you a point. Remember that if you know one gradient, then you could simply find the other one because the product of the two must give you negative 1. So those are some simple applications that you need to remember when working with parallel lines and perpendicular lines and finding the equation of a straight line.